ready? You ready? You ready? You ready? You ready? Ready? Ready?
Oh, boy! This is for you, Sasha. We're using a contingency table and we're testing independence. What? First we need to go and we need to get our row totals. That's those there. You can get those by Adam. There has to be somebody out there named Adam. And then what do we want? We want to go get our column totals. So then Adam, and Wilmer did that, so it's on him. So then, our row sum and our column sum should be the same sum. That's the grand sum. That's that 253. Then we need to go get our chi-squared, our test statistic. Statistics excite me. So what do we need? We need to find our expected values. So, to find our expected value, that's the row total times the column total divided by the grand total. Then, let's go get that first one, surgery and success. So our expected value for surgery and success, we take the row total times the column total and divide it by the grand total. And then that's how we got 47.5. Then we're going to go get our expected value of weight-bearing cast and success. So that's the row total times the column total divided by the grand total. And then we get 66.2. So I'm putting that right there. So now we're finding the expected value of non-weight-bearing cast for 6 weeks. That's the row total times the column total divided by the grand total. That was 52.5. I'll put that right there. So then we're finding the expected value of non-weight-bearing cast less than 6 weeks. That's the row total times the column total divided by the grand total. And I put that 58 right there. Now, let me go get the other ones, but I'm going to have to do some quick erasure, because what am I doing? All I'm doing is changing the column total. And we're going to go through and we're going to find the expected value for the surgery and failure. So surgery and failure, I changed that column total and I get 18.5. Then I do the same thing with the weight-bearing cast, and that's how we cast that to be 25.8 great weight, non-weight-bearing cast for 6 weeks. We go and we change that column total, and that's how we got 20.5, and then we keep going and we get that last one. Don't stop, get it, go on to the next page, because what do we need? We need to find our test statistic, and that's what's going on here. Don't mind me putting our values back in there. So our row total, our column total, our total, our expected values, and then we do the same thing for our failures and we get our expected values. That's what you just saw. Replay last time on MathStat. Now, we're going to find our observed minus our expected. That's where we take our observed value, the text value, and subtract off our calculated value. That's what's going on here. And we did the difference. We're rebalancing our weights, as Gus would say. Now all this stuff is just going on here. It's just like fantastic. What do I want to do? I want to recopy my expected and my observed, or at least the difference of. So don't mind me rewriting these guys, doing some stuff over here, doing stuff over there, and stuff is still going on, and now I'm writing over here, and then I'm writing over there, and stuff is still going on. So then we're going on. Yeah, this is where Sasha starts talking. What's that car that Ford makes? Focus. I have my observed minus my expected. Now, let me go and relist my expected, because we're going to use those in our test statistic. Yeah, our test stat. You know, the sum of the difference between the observed and expected divided by the expected. That's why we wanted to put my expected right there. So then I am doing that. That's the difference square. We're going to go and we're going to square each one of those values. All right. So then, after we square each one of those values, Wilmer did that, it's on him. It's the observed minus the expected squared over the expected, and then we're getting these tiny numbers, but they were also checked by Austin. Yeah, so that's on him. And then we go and we get that grand sum. Yeah. It's like the child of our child. No, our grand sum. So our test statistic was 58.46, and Gus, Austin, and Wilmer all checked that. So check this. Now that we got our test stat, boom, what do we want to do? We want to set up our null and our alternative. Our null is that the rows and columns are independent. Yeah, you know what that means. They don't mess with each other. And our alternative is not independent. I should have said, yeah, the rows and columns are not independent, but I got a little tired of writing right now because, like Christina and Claudia, they were all just spacing out. So yeah, our critical value, we're going to need to find that using a chi-square chart. So our degrees of freedom was row minus 1 times column minus 1. That's fun. We had 4 rows and we had 2 columns, making our degrees of freedom 3. Then we chose an alpha level of 0.05 because Gus was comfortable with that, and Gus looked it up, so that's on him. So on our chi-square, right side, test stat, degrees of freedom 3, alpha 0.05, our critical value turned out to be 7.815. We set up our rejection regions. Chi-squared is our right-tailed test, so fail to reject is on the left of our critical value, and reject is on our right of our critical value. And then that star right there, yeah. Oh no, it was supposed to be in black. Like a black widow, baby, we reject our null, that they're independent, and we assume that our rows are independent, our rows are dependent of our columns.